Welcome back. Today I'll be going through a P5 end of year paper. There's 10 set of questions over here, so let's begin. An illness cause cells to reproduce and grow uncontrollably because of the part of the cell that has been damaged. So if you take a look, parts, there's only 5 parts. The nucleus is the cell membrane, the cell wall, the chloroplast, and as well as the cytoplasm. So if you take a look, this is talking about cell division, and the cells itself cannot control itself, and therefore they divide uncontrollably. And this is actually one of the important activity that the cells need to undertake in order for them to grow in number. And if it's grow uncontrollably, right, one of the part that must be damaged that is linked to the this important function will be your nucleus. Okay, the nucleus has been damaged, therefore it divide uncontrollably. Okay, name all its function. Name all its function. Over here there's only 2 functions. Okay, so let me show it to you. The nucleus, it will control all activities within the cell, including cell division. It also contains genetic information that will be passed down from the parent to the daughter cell. Okay, researchers are developing a new treatment to treat and remove growth due to illness. Okay, this growth over here is a collective cell, a number of cells within it that it grows to such an extent such that it grows to an extent such that you can see it without a microscope. Okay, so over here this involves deploying a flexible battery that can wrap around the growth and remove oxygen, okay, of the growth environment. Okay, so this is trying to remove the oxygen. So, and they show you a diagram, the growth and the growth itself is in the middle. After 7 days, the growth decrease in size. So they ask you why did it happen. First thing first, when it decreases in size, it tells you that some of the cell in the growth must have died, and it died because due to lack of oxygen. So over here the cell, right, initially you have to probably say that the cell is a living thing and it needs oxygen to survive. Without oxygen, the cell cannot survive, they will die, and therefore they will decrease in size. Okay, so this part, so let me show you, highlight a key portion. Living cell need oxygen to survive. These are characteristics of living things. Without oxygen, the growth cannot survive, therefore die, decreases in size, which answer back to the question. Okay, the growth did not continue to decrease on day 7. So, and on day 9, a medicine A was introduced and the growth was completely eradicated. Eradicated means remove. Okay, completely means completely remove. That means at some point, right, the size of the growth is 0. 0 units, or there's no cell at all. No cells in the growth itself. So this happened at day 15. So day 15 must be here. Draw the graph of the size of a growth against time. Okay, the axis has been drawn for you. First thing first, you probably know that it started from here, and some of you may have want to draw it in this way, but this is actually wrong. So you take a look, purposely they put 7 and 9, and they tell you that they did not decrease. So they did not decrease on day 7. That means before day 7, decrease. 7 to 9 did not decrease. 7 and 9 did not decrease means it remains the same. Okay, 9 onwards decrease until 0. That is what it means. So I'll probably draw it somewhere here. Okay, let me draw as straight as possible, and then I'll draw horizontal, and then I'll draw all the way down. Okay, this should be how it looks like. Let me use black color to indicate all the 3 sections. Okay. On my iPad it was not drawn so nicely. Okay, it's about there. Okay, let me just. Okay, if I have a ruler, I might draw it better. Okay, so it looks something like this, and this is how it looks like. Decrease. 7 and 9 remain constant, then decrease until 0. So this is how the graph would have looked like. Okay, so let's move on to next part. Okay, Jermaine obtain similar leaf and remove the air trapped inside the leaf so that the leaf itself probably can sink into the water. Okay, this is a experiment that is related to photosynthesis. Okay, which is actually a P6 topic, but some schools they teach it at P5. So she punched the leaf disc from the leaf and placed 10 leaf discs in each beaker. So over here, they take the hole puncher, when take out the leaf, and then this is a sample. Okay, let me break down line by line. This tell you how they prepare the sample preparation. Okay, so and she put them in each of the beaker with X, Y, and Z filled with 10, 15, 20. So what I'm going to do, I'm going to put it here, 10, 20, 15, and 20. Okay, so of substance R respectively. So substance R increases the amount of carbon dioxide in water. So that means more R, more dissolved carbon dioxide. So she placed the beaker in dark room. Okay, dark room, so tell you no light. Okay, so another thing for you to take note is this word respectively. This word actually have some meaning. Okay, it means that X is 10, Y is 15, Z is 20. This is what it means when they use the word respectively behind. And this is actually how scientists actually use these to write their papers as well. Okay, so bubbles were observed in all containers. The bubbles formed were counted over the span of 1 minute, and the table below shows you the result. So if I were to plug in the number, right, 10, 15, 20%, okay, you'll notice that the smallest number, you got the most bubble. The smaller number, the larger the R, you got the smallest number. Okay, so let me repeat this part. You got a smaller R, you got more bubbles. You got larger R, you got less bubbles. Okay, so naturally they ask you what is the relationship between the concentration of R. Notice this is the word that they use. Concentration of R versus the numbers of bubble produced in 1 minute. So these are the two exact phrases that you use. You can just use this exact phrase. Okay, so this is actually how I would answer it. I would say as the concentration of R increases from X to Z, the number of bubbles produced in a minute decreases. Okay, or you can say the higher the concentration of R, the fewer the number of bubbles produced in 1 minute. Is actually they mean the same thing. Okay, so let's move on to the next question. Explain why the number of bubbles observed were different in each of the beaker. So they're asking you this, how come they have different bubbles? Okay, different bubbles come from different concentration of R. That is something that you need to understand first. But let us go to this part before we understand how to answer this part. Okay, the key part is the leaf, right, itself, right? They are in darkness, so itself the leaf will respire, and they respire, they will give out carbon dioxide gases, not oxygen. Oxygen is for photosynthesis, but when they respire, they give out carbon dioxide gases. So for them to respire, they need to take in oxygen, and this oxygen is found where? Inside the water, because the leaf disc is in the water itself. Okay, so let me give you the context of the question first. before we answer this, because this question is a bit tough. Okay, so the context means the background story. This experiment is actually carried out in a dark room. Okay, with the leaf disc placed inside a solution containing baking soda. Baking soda is actually your substance R. Okay, this is actually a source of carbon dioxide. So there's no light. The leaf discs are actually carrying out respiration, not photosynthesis. So now the main focus is how increasing the concentration of R, which is the baking soda, affect the rate of respiration, which is indicated by the bubbles over here. As you can see, when there is no light, the leaf will respire. So when they respire, they will give out carbon dioxide bubbles. So if there is less oxygen, then they will give out less carbon dioxide bubbles. If there is more oxygen, they will give out more carbon dioxide bubbles. And this probably got to do with your R. Okay, more carbon dioxide bubble is linked to less R. Okay, less carbon dioxide is linked to more R. So essentially, if you put more R in, right, you actually got less dissolved oxygen. So less dissolved oxygen, the rate of respiration will be lower and there will be less carbon dioxide produced. Likewise, if you got less R, the oxygen inside the water will be more. And if there's more oxygen, they will have a higher rate of respiration and they will produce more carbon dioxide. So this is actually how you answer this part. This part is actually quite tough. Okay, because you have to understand how the substance R. Okay, this R and this R, realize they are very similar. This R means substance R. Okay, this R means respiration. Perhaps I should spell out the whole thing next time. Okay. Okay, so when there is more substance R, there is less oxygen. That's what I mean, and you will produce less carbon dioxide by the leaf. Okay, so this part I'll show you the explanation. So the explanation goes like this. As the concentration of R increases, the amount of dissolved carbon dioxide in the water increases. How I know this actually is over here. R increases the amount of dissolved carbon dioxide in the water. So there must means that there is less dissolved oxygen, because the amount of air in the water is quite limited. If you've got more of carbon dioxide, that means there will be less of oxygen. Okay, so this lead to a decrease in the dissolved oxygen. So with less oxygen, leaf disc has a lower rate of lower respiration rate, produce fewer carbon dioxide. So then you relate to this. Different concentration of R will result in different bubbles produced by the leaf disc. So this part over here, the answer is viewing this. Okay, so Germaine repeat the whole experiment, but this time round she apply oil on the leaf disc in beaker X and repeat. So it seems like she's trying to tell us this one got oil, then Y and Z got no oil. And remember, all of them have different R, different concentration of R. Okay, so and told her that this was not a fair test. Would this be a fair test? No, straight away no, because there is now two change variable. In a fair test scenario, there can only be one change variable, and this how you could have answered it. There is two change variable. Okay, this you can put a comma. The concentration of R and the presence of oil on the leaf disc. So you must state this part. Okay, you cannot just say there's two change variable, this is not a fair test. It's not how it works that way. You must state what is the two change variable that is involved in the experiment. Okay, which is the concentration of R or different amount of R, as well as the presence of oil. So in a fair experiment, there can only be one change variable. Then you can state clearly. This is actually how you'll be able to fulfill this 1 mark over here. Okay, so let's move on to this part. Tom has a farm growing plants like the one that I showed below. Part B of the plant can be collected and used as food. So over here, this part is actually part of your root systems, and sometimes we call it your storage roots. Okay, which is fruits that looks like this plant over here will be your potato or your carrot. Okay, so part B store food. Which part of the plant made the food which is stored in B? This one obviously must be the leaf, because the leaf made food for the plant. Okay, and this, as you can see, you got part A and part B, and they tell you how the food got transported. So naturally, this is a plant transport system question. Okay, plant transport system. So whenever plant transport is involved, right, things like food carrying tube, water carrying tube, must be mentioned, okay? Or at least you will need to relate to them. Okay, so how the food got transport to B, and how is it being stored there? So usually we will say, where is it from, through what to where. Through what is usually your tube, which is found inside the stem. Okay, so this is how you could answer. Food made in the leaf, this one very important. Tell me where's the source. Okay, transported, as much as possible use this word. Okay, through the food carrying tube to part B. That's all. Okay, Tom measured the average weight of part B of the plant on 8, 13 and 18 day, and recorded the result in the table over here. Okay, and it shows you that when the day increases, the mass of the part B is also increases. So Tom made a cut around part A of the stems and remove the food carrying tube. So the food carrying tube is being removed. He thought that it will make B bigger, but instead it got it smaller. So it already tell you a claim. In the question already got a claim. So you just have to give some of the evidence and reason to support why part B got smaller instead. And this is how you could have answered. You take a look, when this part is being removed, okay, the food made inside the leaf is represented by green color, right? It actually cannot go down anymore. Okay, so you go to other plant parts, and you notice that this part over here, there is no leaf as well. So if there's no leaf, no food will be transported to the part B. Okay, so you can state that as part of your evidence as well. Okay, so there's no leaf under part A. So that will be one thing. Without food carrying tube at part A, no food from the leaf will be transported to part B. And part B itself, right, because it's a root system, it will still continue to use the food to respire. Okay, and it will reduce its mass. That's why it becomes smaller. The linkage must be made. Okay, Tom's friend visited his farm and saw flowers on his plant. He advised Tom to remove the flower for part B to be bigger. So he's trying to say, if you remove the flower, B will become bigger. Okay, why will doing this cause part B to become bigger? So why when you remove flowers, right, the part B, which is the root parts, will become bigger? It's because when you're removing one of the parts, right, there is less food sharing to different plant parts. Okay, when this happens, then more of that food can be channeled or can be transported to other parts. So this is how you can write it. So you can state the situation. When the flower is removed, no food is transported to it. It refers to the flower. Okay, remove flower, no food, of course, will be transported to flower. Okay, so more. Okay, this part must be stated. More. Okay, more food from the leaf is transported to part B, so cause it to become bigger. Okay, so you link it back to the question. Okay, so the diagram below shows the human lung and an enlarged diagram of one air sac and its blood supply. Okay, this is the lung and itself is the air sac. Okay, and this is the blood vessels. So gas Q, you take a look, the arrow is going into the blood. Okay, gas Q is going into the blood, so this will be oxygen. So whatever they have to remove from the blood will be the arrow pointing out. So that must be your carbon dioxide. So P is your carbon dioxide, Q is your oxygen. Okay, part S of the air sacs is only one cell thick. So when it's trying to say this one cell thick, not many cell thick, it's trying to say that it's very thin. Okay, how does it affect the time needed for the gas exchange to take place? So gas exchange could take place is either very fast or slow. So they're asking you, making it very thin, okay, is it going to be faster or slower? Obviously it's going to be faster because it's easier for it to pass through now when it's very thin or one cell thick. Okay, it's not about the thick, it's about one cell, and therefore it is very thin. Okay, that the connection here is very thin. Okay, let me highlight this part. So it can enter into the bloodstream very easily. Okay, name another gas not mentioned in A that can be found in the air sac. So it cannot be carbon dioxide, it cannot be oxygen. Okay, so you probably know that when you breathe in air, right, it consists of 4 main height. Okay, and sometimes it will include in your MCQ. So there will be the oxygen, the carbon dioxide, the water vapor, as well as your nitrogen. So as long as you say water vapor or nitrogen, I think it's good enough. Okay, so this will be the key part. Just one of that will be good enough. Okay, the air sac in the lungs are very small, very numerous, so many, and they are small in size. So when there's many and small in size, right, how would this benefit instead of having 2 large air sacs? Okay, this is actually a surface area question. Okay, and it's exposed surface area because we are talking about gas versus your liquid, which is your blood. Okay, so whenever gas is involved or gas is involved in the surface area question, right, normally we will use or at least include the word exposed. Okay, because the surface area, right, is not in contact, it's basically exposed to the surrounding air, okay, or surrounding gases. So that's why we will use the word exposed. Okay, but when to use surface area? When it's nothing to do with gas. It could be solid to solid. Okay, solid to solid, solid liquid, or liquid liquid. Okay, so as long as got to do with gas, then we will more or less use exposed surface area. This is why also when we talk about rate of evaporation, we use the word exposed surface area. Okay, so over here when you have many, right, and small, you are trying to increase the surface area. So when you have a greater surface area, your gas exchange will happen much faster. Okay, so gonna show you this part. Okay, many small air sacs increase the exposed surface area for a faster rate of gas exchange. Okay, on this part, I think this part will be good enough. But if you want, you can say for faster rate of gas exchange of oxygen and carbon dioxide between the surrounding air as well as blood vessels. Okay, I think that will be even a better answer. Okay, so CT found plant A and plant B in the garden. Okay, the plants were from the same species but have flowers that look very different. Okay, the below shows the flower found on each plant. Okay, so you see A, these are all your anther. Okay, but there's missing this part, the stigma or the style or the ovary and ovules. They are all missing. Okay, so normally when we see this, right, this one female absent, that means no female heart. Okay, when we see this, okay, this part will be female present. Okay, so you take a look at this question. Whenever it's a fruiting season, observe that fruit only appear from one of the plant. Which plant, A or B, will fruits be observed? Okay, so if you want to know which one or which plant will have fruits, right, first you must find the flowers with female parts present. Okay, this is the key, because the female part is the one that will develop into fruit. Okay, this is the case where you can use choice evidence reasoning, because they can ask you to make a choice. Okay, A or B should be B, because B they have the stigma, the style, the ovule inside, and the ovary. Okay, so with that you can have pollination, you can have fertilization. When you have these two things, you can develop into your fruits with seeds. Okay, so let me show you this part. So the choice B, it tell me it has a female body part such as stigma, style, ovary, or you can just tell me flower B has stigma, style, and ovary. So it can be pollinated, can be fertilized, or you can say pollination and fertilization can occur. So and the fruits will be developed. Okay, you can continue to say that A do not have a female reproductive part, so it cannot be pollinated, it cannot be fertilized. Okay, so no fruit will be developed. So this part is more or less quite straightforward. Okay, so the diagram below shows two different dispersal patterns. Okay, did you know that the seeds of the fruits produced by this species of plant is small and dispersed by animal? Okay, which diagram shows that shows the dispersal pattern of the plant? Okay, usually when it's dispersed by animal, right, it's very random and it's quite far apart from each other. Okay, so this part over here is really diagram 1, because over here they are all far apart, and as compared to this, right, they are more or less clustered around. It looks like this one is more towards from splitting rather than animal. Okay, and if you notice, right, this one is not in the direction of wind, because if it's in the direction of wind, you will not find this over here. Okay, because all of the seeds will be in this in this manner. So definitely this is not wind as well. Okay, so some of the explanation you could use is, okay, diagram 1, because they are scattered randomly. Okay, that will be the key part. Okay, animal is always random, you can't control the movement of animals, so that will be the key portion that you will identify. And the seeds are further away from the parent plant as well as from each other. Okay, they are far apart. Okay, they are, as compared to X, I would say Y will be more far apart. Okay, and they are not in the direction of wind. Okay, but the first two reasons will be a stronger reason, okay, as compared to the third one. Okay, why is it important to carry out seed dispersal or for the seeds to be dispersed? Okay, this will be I think most of the time you probably relate it to reduce overcrowdings. Okay, you want to reduce competition. Okay, and you reduce competition for sunlight, water, space, and mineral salts or nutrient depending on your school's requirement. Certain schools we may ask you to write mineral salts, certain schools may ask you to write nutrients, certain schools they allow both. Okay, so these are more or less the 4 factors that you probably need to remember. Okay, and another part, most of the time, right, you will write something like most of the students, they will write something like compete for food. No, they also don't compete for air. Okay, even though the plants can be very close to each other, they don't compete for air because air is always in the surrounding. They cannot compete for air. They cannot compete for food because they are not animals. They don't hunt for food, so they cannot compete for food. But they compete for sunlight because sunlight is the one that helps them to make food. So they cannot compete for food, yes, but they can compete for sunlight. Okay, so these are the 4 main portion. It's critical for you to know what they compete for. Okay, sunlight, water, space, mineral salts, or nutrients. Okay, so So Timothy has two containers P and Q. They fill them out with same volume of water, so they are the same. So over here they tell you that this area over here, or no, they tell you that the diameter is 12. So the exposed surface area, ESA stands for exposed surface area, they are the same. Initially, they are the same. Okay, so in which setup will the water take a longer time to evaporate? Will be this. Because over time, right, when more of the water evaporate, right, you notice that the circle become smaller and smaller. It's trying to tell you that the exposed surface area becomes smaller. Okay, with a smaller exposed surface area, evaporation will be slower. Okay, so it will take a longer time to evaporate all the water. Okay, so this is something that you could have explained. It's a 2 mark. I think you need to explain a little bit longer. So you can say setup Q, that will be your choice. As more water evaporates, the exposed surface of Q will become smaller as compared to P. Okay, P will remain the same because the circle over here, if I were to draw a circle, the circle remain the same. Okay, the circle remain more or less the same as more water evaporate. So the exposed surface area, right, remain the same and it will not change. Okay, but Q do change and they change smaller. So the rate of evaporation decreases as more water evaporates. So end up it will take a longer time to evaporate all the water. Okay, after playing soccer, Timothy switched on a fan and blew it on his own. Fan always related to wind. And wind will be a factor that will affect rate of evaporation. More wind, rate of evaporation increases. He realized that his perspiration dry faster. It means that the sweat, right, become water vapor faster. Okay, with the fan turned on as compared to without fan. With fan, evaporation is faster. Without fan, evaporation is slower. So this part, right, there is 2 portions. First, you got to probably tell me that the sweat actually gain heat from his body to evaporate into water vapor, and with the fan it increases the rate of evaporation, therefore the water evaporate faster. So this is something that you could have write. Okay, so the fan produce wind increases the rate of evaporation. First you have to make the connection. So then next, the perspiration gain heat faster from his body. Why from his body? Because the perspiration will more or less found on his body itself, on the surface of skin, therefore evaporate faster into water vapor. The word faster here is to show comparison with and without the fan for this part. So you probably need to write that down. Okay, so let me go on to the next part. So Margaret wanted to find out the volume of the water bottle, so she filled out the brim with 300 centimeter cube of marble as shown below. So over here the marbles are 300 centimeter cube. Okay, tick the box to show the volume of the bottle. So the bottle, right, is this whole thing. The marble is only 300. They ask you, would it be less, equal or more? It will definitely be more, because over here is 300. There will still be air. This air also has some volume, because the air also occupy space. Okay, because of that, right, it must be the bottle will be equal to the marble plus air. So if the marble is 300, the air is some unknown number, therefore it must be more than 300. Okay, so explain your answer. Basically they ask you why you put a tick over here. Okay, put a tick over here is mainly because the marble itself is solid, has a definite shape. I'm trying to use the property of matter to explain this, and because of it having a definite shape, it cannot match the shape of the container, okay, or the bottle itself. So there will be air over here. This air is occupy space as well. Okay, therefore the answer must be more than 300. Okay, so it is solid, definite shape. It cannot match the shape of a container. So because of that, there will be air gaps between the marble. Because of this air gap, the volume must be 300, because the air gaps itself also occupy space. So you can see this part, there are a lot of words that are used that is related to the property of metal. Okay, Margaret uncorked the water bottle above and tried to squeeze 3 more bubbles in it. Will she succeed? Definitely not. Okay, why? Because the marbles already at its brim. Okay, you try to put more, you will not be able to squeeze it because the marble itself is solid, and this is the time where you decide, is it volume or shape? It is volume. Okay, because you are trying to push more, right? It's the act of compressing, and you notice that you cannot do it, or you cannot push the marble down, is because it cannot compress. If it cannot be compressed, it must have a definite volume, and this is actually how you link this part. Okay, so explain your answer in terms of property of metal. It will be this. Okay, it is still a solid, definite volume, cannot be compressed to occupy a smaller space in the water bottle. So she will not be able to succeed to push 3 more marbles into it. Okay, so she tried to replace all the marbles in the bottle with sponge ball of the same size. So you know sponge ball, you can squeeze it, and when you're squeezing, you're actually squeezing the air out. Okay, so she tried to squeeze 3 more sponge ball in the water bottle. Did she succeed? Yes, this time yes. But this time it's not because the solid itself, it can be compressed. No, it is still solid, but it's the air inside the sponge that allow it to be compressible. Okay, so let me show you this part. You can say yes, this is a contrasting question. So I will say something like, although the sponge is solid but it contains air inside, is the air inside that has no definite volume because it is a gas. Okay, and it can be compressed to occupy a smaller space in the water bottle. Okay, therefore you are able to squeeze them into it. Okay, so why smaller space in bottle? Because you want to try to relate, are you able to squeeze it? And if you do squeeze it, is because the sponge ball itself is being changed to a smaller space, and that is related to it having no definite volume, and this is related to the air inside. Okay, so if I were to make this even a better answer, I would say the air inside is a gas and has no definite volume and can be compressed. Okay, these two always come hand in hand. Okay, no definite volume can be compressed, so try to write them together. Okay, so 36 is on light. Okay, the setup below use light sensor to count the number of people entering the room. Okay, so when there is no people entering the room, right, the light source will hit the light sensor and it will detect most light because there is nothing blocking it. Explain how the setup is able to count the number of people entering the room. Okay, so when the people enter the room, it will start, the light will be blocked, and when it's blocked, no light can reach the sensor. So when there's no light, there's someone entering. Okay, so when the people pass through the light sensor, it blocks light. This part is important, from the source to the sensor. So why this two part is important? Because this two part is probably the words that has been given in the diagram, and probably it's always best to use these words in the diagram itself: source, sensor, and that's how you make connection to the diagram with your answer. And no light will be detected. So when there's no light detected, means someone passed through. Okay, at any time, only one person can enter the doorway. As each person is passing through the doorway, the light sensor record the data. The data is shown in the graph below. So you have the amount of light by the sensor, and you have time. Okay, so this part is the part, this few parts is the part that is no people entering. Okay, when it goes down all the way to 0, that means there is people entering. Okay, so you just have to count the number of time it reaches 0. Okay, we're doing that for a second. So 1, 2, 3, 4, 5. So 5 people. Don't just leave it at 5. Okay, just 5 people. Okay, give the units as well. The units is in people. Okay, the light source and the sensor are placed at 110 cm above ground. State whether a child who is 90 cm tall can be counted. Explain your answer. Okay, definitely no. Okay, so this is the door, right? So over here is 110 cm. This is the light source. So if the child is 90, okay, the light will still pass through and hit the detector. So over here, the child over here will not be counted, even though he passed through. Okay, not counted. Okay, and the reason is it cannot block the light. Cannot block the light. So over here, the key part is whether the person is tall enough to block the light or not. Okay, so the child is not tall enough to block the light. Okay, and all the light from the light source will be detected by the sensor. Okay, that's all you probably need to write to be able to fully explain the question. Which property of light can be demonstrated? This will be light traveling in a straight line, because light traveling in a straight line, they don't bend. If they can bend, then I would say that the person who is 90 cm tall can be detected, because it might bend lower to hit the person and no light will be detected by sensor. But you know that's not the case. Okay, that's not the case for this. So this will be the key property for this to work. Okay, study the circuit below. When the switch was closed, Sally observed that the iron ball moved up and down. So it moved up and down from between A and B repeatedly as the bulb blinked continuously. Okay, this part over here, you have to take note. The bulb blink continuously. When the bulb blink continuously, it means that it light up and it don't light up. When it light up, it's because it's closed. When it don't light up, it's because it's open. Okay, when it's closed, the ball must be at A. When it's open, the ball must be at B. So that's how you make the connection. And what causes the ball to become A and B must be the iron bar. The iron bar has some coil. The coil will make it to become an electromagnet, and it will somehow attract the iron ball. Okay, so this part, there's two parts. The one that is lighting up, the one that is do not light up. Okay, the one that is not lighting up. Okay, so this is how you can answer this part. Okay, the answer is a bit long, so I put it here. Okay, so when the light bulb light up, okay, this is how you can explain, which is the first part. When the switch is closed, electricity flow through the circuit and the circuit is closed. So the light bulb light up. When the circuit is closed, the light bulb straight away light up. Okay, the iron bar becomes electromagnet, attracting iron ball from A to B. Okay, which is this part. From A to B. So the iron ball is now at B. So when it's at B, right, there will be a gap over here. You can say there is a gap, but the key explanation that you must say that it is open. Okay, there's a gap because then the circuit will be open. Okay, so this is the part, the second part. So the light bulb does not light up. There's a gap at the metal contact. So notice I use the key phrases that has been given to me. Electricity cannot flow through. The circuit is now open. Because now when the circuit is open, the light bulb does not light up. The iron bar loses its magnetism, causing the iron ball to drop from B to A again. So the iron ball will drop back. Okay, so when it drop back, it will close the circuit. The whole process repeat itself. Okay, so if you want, you can add this part, closing the circuit. That will make the answer even more perfect. Right? And you know that if it's closed the circuit, then you will come back to this situation again, which is 1. Okay, and then the whole process repeat itself. Okay, Sally wanted to replace the iron ball with another object. Okay, state 2 property of the object which will allow the bulb to stay lit and not blink when the switch is closed. He's trying to say, right, this part, for the lid for the bulb to remain lit, right, it's trying to say that I only want the circuit to be closed and not open. Okay, for this to happen, that means the ball, the iron ball, must always be at A. Okay, must always be at here. So for this to happen, the iron ball cannot be attracted by electromagnet. So what kind of ball will not be able to attract the will not be attracted by the electromagnet, yet still can conduct electricity, because you still want it to conduct electricity. On this part, you still want it to flow through the iron ball or the ball itself, okay, to close the entire circuit. So number one, it must be a conductor. Number two, it cannot be a magnetic material. So you can use maybe copper or aluminium, but just not iron, steel, or any magnetic material. So this will be the two part. This is just a state part. So non-magnetic material, conductor of electricity. The light bulb will just remain lit, it will not blink. Okay, so this part I think should be alright. Okay, let's go to this part. Okay, this question is on energy. Okay, so Oscar set out a circuit below using using a lemon and two pins and a light bulb and some wire. So basically the lemon is kind of like an energy source. Okay, and electricity flow through this part, probably here, to light out the light bulb. Okay, and it seems like that lemon seems to be our energy source. Okay, so state the energy conversion. The energy in the lemon will be our potential energy, and it's in chemical form. Okay, and when the pin is connected, electricity actually flow through the wire, so it's electrical energy. And when the light bulb light up, it will be light and heat. Okay, as well. So this will be the energy conversion for this setup. Okay, next up. Okay, this is a water cycle question. Okay, so a media conductor experiment below, you have a heater, you have water, you have a dish, and you have glass beaker as well as metal tray. Then they ask you straight away, how is the water collected? How is the water collected from the dish? Okay, so basically the water is in liquid state. Over here, the water in the dish is in liquid state. How can the water travel to this part? It must involve a change of state. So what happens is that the heater, right, will cause the water inside to evaporate into your warm water vapor. And then this warm water vapor probably came into contact with this metal sheet and it start to lose heat. When it lose heat, it become back your water droplets. And it slowly drip it off. Okay, so over here, this is your liquid, then it changed to your gas. So this part, evaporation. From your gas, it changed back to your liquid. So this part is your condensation. Okay, so there's two parts, evaporation and condensation. Okay, explain how the water is collected into the dish. So I'll elaborate the steps. So part 1 and part 2. So on part 1, this will be evaporation. The water inside the beaker, so I'll state where is it from. Gain heat from the heater, evaporate into water vapor. So there's actually 4 parts. Where is it from? The heat transfer process, and the heat is gaining from where? Evaporate into your water vapor. Okay. Next, the condensation with your warm water vapor, which comes from the evaporation process, loses heat to the cooler metal sheet. Okay. The word cooler must be stated. Condense into your tiny water droplets, which then drip into the dish itself. Okay. So when the dish was filled with water, another similar dish was used to collect the water. It took you a longer time to fill up the second dish. Okay, so this time round, it seems that the water droplets took a longer time to fill up the dish. Right? It means it condensed slower. Okay, the building of the water droplets is now much slower. That's why it take a longer time to fill up the second dish itself. And you notice that this part, right, when the metal tray, right, which serve as a condensing surface for the water for the water vapor to condense on, right, it will eventually gain heat. And it gain heat from where? It gain heat from the warm water vapor. Okay, so temperature will start to rise. It will become less cooler over time. And because of it, the warm water vapor that's coming out from the next round in this question will actually lose heat, but it will lose heat slower. Okay, for this part, for question part B. So let me show you this part. Okay, so first up, you can answer it in this way. That there's two ways to answer this. Okay, the metal tray gain heat from the warm water vapor become less cool. So when the warm water vapor lose heat slower, condense slower into tiny water droplets, right? Or you can say into less tiny water droplets. Okay, because if you lose heat slower and condense slower, you will definitely produce less. Okay, so another way is to state this part. This part will be a better explanation, but sometimes it's a bit hard for you to come up with this. Okay, so same thing, metal tray gain heat from the warm water vapor and become less cool. So trying to say the temperature of the metal tray increases. So because of this, there's a smaller temperature difference between the water vapor as well as the metal tray. So the rate of condensation is lower. So one of the factors that affect the rate of condensation will be your temperature difference. Okay. If it's larger, then there will be more condensation. If it's smaller, there will be less condensation. Okay, for this part. Okay. So let's move on. So either answer before we move on, either answer will be fine. Okay. So you just have to write one of them. Okay, the experiment was repeated in the glass box attached to a vacuum pump that removed air from the glass box at regular interval. So this warm water vapor that actually came out from the evaporation process will be removed, okay, by the vacuum pump into the surrounding. So when this happens, right, then it will have less warm water vapor to begin with, at least in the container itself. Then they ask you, what effect would this have on the amount of water collected in the dish? If you have less, then you will have less condensation as well. If you have less condensation, then you have less water droplets, okay, falling into the dish. So the amount collected will be less. So it's more of a trickling down effect where you start out with less of something, then you end up with less of something. Okay, so this part is how you can answer this. So the choice, less water collected, so some of the warm water vapor will be removed by the vacuum pump. So this results in less warm water vapor losing heat and condense into fewer tiny water droplets. After the experiment, Amelia washed the hot glass beaker under the cool tap. The beaker cracked. Okay. This one, it cracks, right? It is mainly due to the expansion and the contraction process. So when you wash the hot beaker under the under the cool tap, right? I suggest that it should probably be the outer layer of the glass, right, actually loses heat to the cool tap water. So when it loses heat, it will probably contract. But the inner layer, which is this part, let me use blue color, it is still hot. Why is it hot? Because it is hot, heated up by the heater. So this will probably expand. Okay, so one side expand, one side contract. Definitely it will cause it to break, because there is one of them is increasing in volume, the other one is decreasing in volume. Okay, so over here, the inner layer of the beaker gain heat, expand, but the outer layer of the beaker lose heat to the tap water and contracted, causing it to break. Okay, this will be part of the explanation itself. Okay, so with that, we more or less come to the end of the paper, so you can pause at different time section to look at the answers again. Okay, thank you.